Level 1. HDD, the hard disk drive. The oldest trick in the book. Inside this thing is a literal spinning metal disk and a tiny mechanical arm that swings back and forth over it, reading your data, like a vinyl record player. Except instead of music, it's storing your entire digital life. And it works. Your files survive when you turn the power off. You can store terabytes for almost nothing. For the price? Unbeatable. But here's the catch nobody talks about. That arm has to physically move to find your data. Every single time. And that movement takes time. Real, mechanical, agonizing time. That computer that takes 4 minutes to boot? That's an arm dragging itself across a spinning disk, desperately looking for windows. Oh, and it's fragile. One bad drop and that arm scratches the disk. Your data is gone, just like that. This is level 1. Cheap, massive, slow. Everything above it exists because this wasn't good enough. Level 2. SSD. What if you remove the spinning disk? What if you got rid of the arm entirely? That's the SSD, solid-state drive. No moving parts, just chips. Data stored electronically, accessed in an instant. The difference in real life is shocking the first time you feel it. 5 to 10 times faster than an HDD. A computer that booted in 4 minutes now boots in 10 seconds. Programs open before you finish clicking. And because there's nothing moving inside it, it's durable. Drop it, throw it in a bag. It doesn't care. Here's the mini payoff, and this matters. The reason your old computer felt slow wasn't the processor. In most cases, it was never the processor. It was the HDD. Swap it for an SSD, and the same hardware feels like a different machine. People spend hundreds on upgrades when a $50 SSD swap would have solved everything. Level 3. Fast SSD. So, if removing the spinning disk made things 5 to 10 times faster, what if we changed how the SSD connects to the rest of the computer? That's NVMe, Non-Volatile Memory Express. Same idea as an SSD, but instead of the old SATA cable, it connects directly to the CPU through the PCIe lane. Speeds of 3,000 to 7,000 megabytes per second. Compare that to 550 for a regular SSD. You're not on the fast road anymore. You're on the highway with no exits. But here's the honest truth. For everyday use, browsing, documents, streaming, you probably won't feel it compared to a regular SSD. The bottleneck moves somewhere else entirely. And that somewhere else is what we're getting into right now. Level 4. RAM. Everything up to this point has been about storage. Keeping your files when the power's off. RAM is something completely different. Turn off your computer. RAM forgets everything instantly. Every single thing it was holding, gone. It has no memory of what happened 5 seconds ago. So why does it exist? Because your drive, no matter how fast, is nowhere near fast enough for your CPU. The processor is doing billions of operations per second. Having it wait for the SSD every time it needs data would be like a Formula One car stopping at red lights. RAM is the solution. Think of it as your desk. The drive is the filing cabinet across the room. RAM is everything spread out in front of you, within arm's reach, right now. When you open Chrome, Photoshop, Spotify, and somehow end up with 40 tabs, all of that is on your desk. Your CPU grabs any piece of it in microseconds. No trip to the cabinet, no waiting. Run out of desk space? Your computer starts using the SSD as pretend RAM. It's called a swap file. Technically it works, but your SSD is thousands of times slower than RAM. Everything stutters. The computer is basically drowning. 8 gigabytes minimum. 16 is comfortable. 32 if you do anything serious. Level 5 VRAM. Here's something people miss. Your GPU doesn't share RAM with the rest of your system. It has its own, completely separate, built into the card itself. That's VRAM, video RAM. While your CPU handles a few complex tasks at once, your GPU is doing thousands of simpler ones, simultaneously, rendering every pixel, every frame, every texture, dozens of times per second. It needs data constantly. VRAM is right there on the card, instant access. No waiting. Run out of it? The GPU reaches over to system RAM like a desperate roommate borrowing your stuff. Your frame rate collapses. But here's the part that surprises people. VRAM isn't just for gaming anymore. Running AI models locally, generating images, anything with machine learning. VRAM is the bottleneck. Not your CPU, not your system RAM. The VRAM on your graphics card is the wall you hit first. And right now, that wall is expensive to move. Level 6. Cache. We need to talk about something invisible to you, but running constantly, billions of times a second, right now as you watch this. Cache memory. Even RAM is too slow for the CPU. The processor runs so fast that waiting for data to travel from RAM to the chip is a real, measurable delay. So engineers put a tiny, extremely fast stash of memory directly on the CPU itself. L1, L2, L3, 3 layers. L1 is maybe 64 kilobytes right next to the core. L3 can be 32 megabytes on a high-end chip, tiny numbers, full processor speed. Cache hit, data's already there, grabbed in nanoseconds. Cache miss, it goes all the way to RAM, which feels, from the CPU's perspective, like waiting for a letter to arrive by mail. That 32 megabyte L3 cache versus 8 megabytes, that's not a spec sheet detail. That's the difference between a chip that breezes and one that constantly waits on itself. Level 7. CPU registers. And now we're here, the top. CPU registers, not megabytes, not kilobytes. A few dozen slots, each holding 64 bits of data. That's the whole thing. But here's what makes them different from everything else on this list. Registers aren't memory you access. They're memory you are. When the CPU performs a calculation, adds 2 numbers, executes an instruction, the data has to be in a register first. That's where the work literally happens. Not nearby, not close to the chip, in the calculation unit itself. If RAM is your desk and cache is the closest drawer, registers are the pen in your hand, the thing in contact with the work. 1 clock cycle, sub-nanosecond, billions of times per second. Every video you've ever watched, every game you've ever played, every message you've ever sent. At some point, all of it passed through a handful of tiny slots inside your processor, moving so fast that the concept of fast stops meaning anything.